Prudent Scholars in association with Goa Headmasters Association.
Hello students, in today's class we will be learning about acids, bases and salts. So you can see on the screen there are various food items which are kept, okay. Bitter gourd, Lay's and baking soda. Now when we taste these various food items, their taste differs. We know bitter gourd tastes bitter, whereas chips they taste salty. While baking soda, if you have tried to keep the baking soda directly on your tongue, it's going to taste bitter. Now what is the reason for this various taste in the food items? Yes, you have learned this in your previous class. The presence of acids, bases and salts give various taste to the food items, okay. So let us see some food items which contain different types of acids, okay. Apple consists of malic acid, tamarind consists of tartaric acid, tomato consists of oxalic acid, curd consists of lactic acid, ant, the sting of the ant, or you can say the venom of the ant, it consists of formic acid, and vinegar that we use in our day-to-day cooking, okay, to make salads and all, it consists a mild acid which is called as an acetic acid. So you see students over here, these acids which are obtained from the natural sources. I do not have any synthetic product over here, okay, on the screen that you can see. Okay, all these products which are there, these are obtained from the natural sources. That means there are certain acids, okay, which are obtained from the natural sources and are called as organic acids. But those acids which are synthesized chemically either in the lab industry or obtained from minerals are called as synthetic acids. Let us have a look. Okay, so we categorize acids into two types. Okay, we are having organic acids and inorganic acid. Basically, inorganic acid is the term given to the acid which is sourced from synthetic materials, okay, or from the lab as I told you already, or from mineral acids. So here are a few examples. Organic acid examples I have already discussed earlier, that formic acid, acetic acid, etc. While those obtained from minerals, example HCl, that is hydrochloric acid, H2SO4, sulfuric acid, even more we have like nitric acid, HNO3 and so on. So now let us learn about the properties of acids, okay. I am sure all of you all have tried lemon juice or some citrus fruits, okay. So when you taste this fruit, you know you get that sour kind of taste, okay. So first of all, the term acid or the word acid has been derived from a Latin word, okay, and that Latin word is acidus. Acidus means sour. So earlier, back in that century, mineral acids were not known or inorganic acids were not known, okay. So acids were known only by their taste. There has been various development in the acids. Later on, Arrhenius concept, Bronsted-Lowry concept came into picture. But in that era, okay, acid means substances which taste sour, okay. Now one of the very important property of acids is their characteristic, okay. That is, they can turn blue litmus into red color, okay, which we will be seeing shortly, and they give H plus ions in aqueous solution. So acids, when you mix it with water, okay, they dissociate to give you hydrogen ions, okay. So H plus ions is common in all acids. Now we categorize acids as strong acids and weak acid depending upon its strength, okay. So here are examples of strong acids: hydrochloric acid, sulfuric acid, nitric acid, okay. These are the strong acids and they are highly corrosive in nature. Now when I say corrosive in nature, it is having a tendency to eat up any metal if it falls on the surface of metal. If it falls on your skin will get burnt, okay. So that is the strength of the acid. Whereas weak acids, you know, weak acids are consumable. Like we have vinegar, which is sour in taste, we add it in salads. So vinegar, that is acetic acid. Then lactic acid, which is found in curd, and then oxalic acid, which is present in various fruit items. So these are examples of weak acid. Now, what is the difference between a concentrated acid and dilute acid? What you have to remember is, okay, concentrated acids, very important, when there is more amount of acid. That means if you are taking 10 ml of acid, okay, and you are dissolving it in less amount of water, say 50 ml of water, your acid will be called as a concentrated acid. Now, dilute acid, it means it contains more amount of water. So, you take 5 ml of acid and you dissolve in 50 ml of water, that means your acid is dilute. So, concentrated acids are those which have more amount of acids, and dilute acids are those which have more amount of water. Okay. So, these were the properties of acids. Now, let us look at the properties of bases. All of you all have tasted bitter gourd or neem, okay. So, when you taste these food items, I am sure you don't like to have it, you want to finish it easily because they are bitter to taste. The soap that you use at your home, okay, it is slippery. You can, if you hold it with your wet hands, it will slip off from your hands. So, bases are bitter to taste, soapy to touch, and they turn red litmus into blue color. They give hydroxide ions in solution. Now, students, you have to know that in case of acids, it used to give H plus ion in solution, whereas bases, it gives hydroxide ion in solution. Example of strong bases are sodium hydroxide, potassium hydroxide, barium hydroxide, okay, calcium hydroxide. These are some examples of strong bases. While weak bases are like ammonium hydroxide, magnesium hydroxide. Okay, magnesium hydroxide in fact is used in as antacids. Okay, you must have heard about the syrups Gelusil. Okay, so magnesium hydroxide is a weak acid and it is consumable. Again, concentrated base and dilute base. Concentrated base consists of more amount of base and less amount of water, whereas dilute base has less amount of base and more amount of water. These are some of the properties of base. Okay. So, in the picture you can see very clearly what is common in acids and what is common in base. Okay. In acids, okay, this is the beaker which is labeled as A. Okay, this beaker is showing you acid, which is the upper part, and water. Obviously, it is miscible. Okay, when you mix it with water, what are you getting? You are getting H plus ion. Okay, so this was the Arrhenius concept of acid, which states that acids are substances which gives H plus ions in aqueous solution, whereas bases are substances which gives hydroxide ions in aqueous solution. Fine. Now, remember students, now here it is being shown as H plus ions. Now, what exactly happens? Okay, H plus ions, when it dissolves in water, we know H2O is the solvent that we are taking, it gets converted into hydronium ion. Okay, so what is present in this beaker is not H plus ion, but it is the hydronium ion which are present in the beaker. But you just have to remember, for example, if I am taking HCl, okay, HCl will dissociate to give me H plus Cl minus ions. So, it is H plus ion which combine with water and give me hydronium ion. Whereas in case of base, let us take example, if I am having sodium hydroxide, NaOH, okay, sodium hydroxide will dissociate to give me sodium ions, that is Na plus hydroxide ion OH minus. Okay, the presence, the number of OH minus ions and the number of H plus ions defines the strength of the acids and bases. More the number of hydrogen ions, stronger is the acid, lesser the number of hydroxide ions, weaker will be the base. Now, point that you have to remember is acids on dilution, okay, the number of H plus ions per unit volume decreases. Whereas in case of bases, same thing, when you want to carry out dilution, what you are exactly doing is you are reducing the number of H plus ion and OH minus ions. Okay. So, what you are carrying out? You are changing the concentrated form of acid into dilute form of acid by changing the strength of H plus ion and OH minus ion, which can be done by simple addition of water. So, now let us see dilutions of acids and bases. Now, remember students, acids and bases, they are highly exothermic in nature. You know the meaning of exothermic means it releases out heat. So you have to take care, there is a proper procedure how to carry out the dilution of acids as well as bases. So the concentration of hydrogen ion in acid, okay, as I already told you, and the concentration of hydroxide ion in base per unit volume shows the concentration of acid or a base. Now, by mixing acid to water, the concentration of hydrogen ion per unit volume decreases. Similarly, by addition of base to water, the concentration of hydroxide ion per unit volume decreases. Now, this process of addition of acid or base to water is called dilution, okay, and the acid or base is said to be diluted. Okay. Now, one of the most important thing that you have to remember, there is a proper method to carry out dilution. Here you can see clearly it is shown that acid is added to the beaker containing water and not vice versa. Now, what will happen if you try to do the opposite side? Suppose I am having a beaker, okay, which is having acid. Instead of pouring acid to water, if I add water to acid, do you think it's going to be the same? No. You're going to cause a mishap. What is actually going to happen if you pour water to acid, the acid is going to splutter, it's going to splash out. And if you are standing right in front, okay, suppose you are having a beaker which is containing acid, okay, and water, if you add water to acid, the acid is going to splash and it may cause burns or it may cause some serious injury. So, keep a point in mind that dilution of acids is never carried out by adding water to acid. Instead, what is being done? A beaker is filled half with water, okay, and acid is poured slowly by putting a glass rod inside the beaker, so that the heat that is released, okay, is very slowly. If it is instant, then it is going to splutter everywhere. Okay. Similarly, in case of base, you are going to add base to the beaker containing some amount of water. Okay. So, dilution of acids and bases, point that you have to remember is that you have to add acid to water and not water to acid. Okay. Next property of acid is conduction of electricity. Acids and bases, both of them, they are very good conductors of electricity in their aqueous form. Now, why in the aqueous form? We know that for the conduction of electricity, what you require is the movement of ions. Okay. Now, in case of acids, we are having H plus ion, and in case of bases, we are having OH minus ions. Okay. So, you can see over here, there are two beakers which are shown, one containing hydrochloric acid, which is a strong acid, and the other one containing acetic acid, which is a weak acid. Now, you see over here, students, what is being done, two electrodes are connected to a battery source and a bulb is being attached. Now, there is, once the ion starts moving freely, okay, the bulb lights. Now, why it is getting lit only in case of HCl solution but not in case of acetic acid solution? Can you think about it? Yes, because hydrochloric acid is a strong acid, okay, whereas acetic acid is a weak acid. In case of hydrochloric acid, there is going to be complete dissociation of the acid into H plus and Cl minus ions. That means hydrochloric acid is going to get completely ionized in the aqueous solution. But in case of acetic acid, we know it is a weak acid. So, acetic acid is going to undergo partial ionization. So, acetic acid will ionize to give you acetate ion, CH3COO minus is called as acetate ion, and H plus ion. But what is the difference? HCl will undergo complete ionization, hence the bulb is lit, whereas acetic acid undergoes partial ionization. That is why the bulb is not lit, because for the conduction of electricity, what you require is the movement of ions. Okay. And one of the most important property of acids as well as base is that they have the tendency to conduct electricity. So, we see there is a wide use of acids as well as bases. So, some of the common acids are given over here. You will be amazed to know, students, that hydrochloric acid, one of the strongest acid, is present in our stomach, which helps in the digestion of food. Okay. Then we are having sulfuric acid, which are used in car batteries. Nitric acid used in explosives, you can see over here in the picture. phosphoric acid, you're always advised by your parents, you know, not to consume these aerated drinks. Now, what is the reason why your parents are telling you not to have aerated drink? Because it contains a mild acid called as phosphoric acid, which of course definitely, you know, it does not allow your bone development. So, a piece of advice, you are not supposed to consume aerated drinks, because now you know it contains a acid called as phosphoric acid, which is used as flavoring. Okay, and then we have acetic acid, which is used in vinegar. Now, what is common in all these acids? You see the formula H, 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 H and H. That means your H plus ion is something that is common in all the acids. Okay. So, what is common in bases? Sodium hydroxide, it is used in soaps, it is used in drain cleaner. Magnesium hydroxide is used as antacid. So, when you overeat, you know, you get that burning sensation. Now, why do you get burning sensation? Because you know your stomach contains of hydrochloric acid, and when you overeat, the amount of hydrochloric acid increases, okay, and you get your burning sensation near your chest, which is not, because now why you should not, and this problem is called as acidity. Now, why is acidity harmful to you? Because it is going to change the pH of your blood. Okay, so that is why you must have seen your parents, okay, they do not eat anything that is oily, because some of them suffer from this acidity. Okay, so in order to get instant relief, what we have is something called as Gelusil tablets. You also get it in the form of syrup. You must have heard of Eno, which is a fruit salt. Then you must have heard of Digene. Okay, so what is common in this? You are consuming a mild base, which is magnesium hydroxide, also called as milk of magnesia. Okay, so these tablets like Gelusil or you know Digene, they are called as antacids, because what they are doing is they are reducing the acidity in your body. So you see how important acids and bases play in our everyday life. Then we are having aluminium hydroxide, which is used in deodorants. Also, it is being used in antacids as a combination drug. Okay, so these are some of the common bases. Now, students, you can see what is common in the formula. You are having hydroxide ion, which is common in bases. So, let us briefly differentiate between acids and bases. Acids is a substance that produces H plus ion with water. Okay, whereas a base is a substance that produces hydroxide ion in water. Strong acid ionizes completely in water. Example, you are having over here HCl, that is dissociating to give you H plus and Cl minus ion. Let me tell you students, the strongest acid known is called as sulfuric acid, that is H2SO4. Now, why it is the strongest acid? Because sulfuric acid, it dissociates to give you H plus HSO4 minus ion. Okay, hydrogen ion and hydrogen sulfate ion. This HSO4 ion further undergoes dissociation to give you H plus sulfate ion, that is SO4 minus 2. Now, if you see the difference between HCl and H2SO4, in case of HCl, there is only one hydrogen ion that is produced. But in case of sulfuric acid, there are two hydrogen ions that are produced, making it a very strong acid. So, sulfuric acid is one of the strongest acid. Okay. Among bases, strong bases again completely ionize in water, and one of the strongest bases is sodium hydroxide, also known as caustic soda, okay, which dissociates to give you sodium ion and hydroxide ion. So, next we will learn about pH. You can see I have written the full form of pH, very important, potens de hydrogen. Okay. The meaning of potens is power. Okay. It is derived from a Greek word. Okay. So, Greek word for power is potens, and the word pH, okay, comes from this potens de hydrogen, that is pH scale. Now, pH scale is very important students, because it is called as a universal indicator. Now, suppose I am having two beakers. Okay. These beakers are labeled as A and B. Okay. Now, you see I do not know, both the beakers are transparent. We do not know what is there inside the beaker. Now, if I want to know whether it is an acid or base, I want something a substance which will make me identify, which will help me to indicate whether it is an acid or a base. Okay. So, and we have learned just now about the strength of acid, whether an acid is a weak acid or whether an acid is a strong acid. Okay. So, see students, if you want to also understand about the strength of the acid, you need something called as a pH scale. Okay. We will be performing the experiment later, but right now let us understand what exactly is a pH scale. So, you can see over here there is a number, there is a paper, okay, which is having different shades of colors, and the numbers is starting from 0 to 14. Now, remember one thing, pH scale, it ranges from 0 to 14. Okay, that is what you can see on the scale. Okay. Now, every substance that you have, okay, everything that you use, it has different values of pH. Okay. You can see over here some of the common substances shown over here. Lemon juice pH 2.0, wine pH 4.0, rain pH 5.5, human blood pH 7.5. Now, what do these numbers indicate? Okay, these numbers indicate, it tells you about the strength of acids and bases. Now, how will you come to know what number corresponds to what? Do not worry, we have something called as pH paper. Okay, so this is a pH paper. Okay, so you see this is a pH paper. You can see the different shades. The shade chart is being given over here. Okay, which is ranging. So 1 is pink in color, 3 is 6 is yellow in color. So you can see it's from till 14 you are having different shades. Okay, and these papers that you can see, these are called as pH papers. Okay, so these pH papers you will use to find out whether a substance is acidic or basic. So let us have a look at an example. Okay, so I take a pH paper and I don't know, this is an unknown solution. Once I dip the pH paper in the unknown solution, students, you can see clearly there is a change in color. Now, what you have to do is, you have to match this color, what you get on the pH paper, to the pH scale. Okay. So, what you have to do, you have to check. Now, if you see over here on this shade chart, okay, the pH value 1, okay, the color on pH value 1 is exactly same as that which is there on the pH paper, which indicates that the solution that I have in beaker labeled A is acidic in nature. Now, how do I come to know that it is acidic in nature? Let us know about it. Remember students, you can see over here clearly, from number 0 to 6, okay, the substances are acidic. That means I have got the color as pink. So, if I, now over here the shades are different, okay, if I relate it to it, my substance, the unknown solution that I have is acidic in nature. It is not only telling me that about its nature, but it is also telling me about the strength. Now, how it tells us about the strength? If the pH value, okay, is lower, okay, say if the pH value is less than 3, then I will say the substance is strongly acidic. Okay, if the value of pH is more than 4, then I will say it is weak. Okay, it is weakly acidic, it is not very strong acid. Okay. Similarly, if the pH 7, you see what is written over here, water, distilled water, okay, it's having a pH value of 7. Okay. When the pH value is equal to 7, we call it as neutral. The other substances that are neutral are salts. Okay. Acids are having lower pH values, salt or water, it is neutral. Okay. And then what we get, the higher the value of pH, okay, the stronger is the base. So, if I am having pH value around say 14, that means my base is very strong. Okay. So, basically pH scale, it tells you about the strength of acid and bases. Okay. I take my pH paper, I am having my pH scale with me. This is the unknown solution B. I dip the pH paper in the unknown solution B. Now, see students, instantly the color has changed. It has not, now it is going to tell me the value when I correlate it with the paper. Okay. So, you see pH value 12, okay, and the color on the pH paper is matching, indicating that the base that is present in this beaker is a strong base, okay. Higher the pH value, stronger is the base, okay. Lower the pH value, weaker is the base, okay. So you see over here, so if your pH ranges, like for example, you can see baking soda, soft soap, these are the items that we are using regularly, okay. Why we can use it? Because they are mild. So lower the pH value, say suppose 8, 9, 10, 11, it's called as a mild base, okay. And if it's higher, it is a strong base. So you can see these are some of the common examples shown over here of values of various items are being shown, okay. There are various. So human blood, you see the pH is 7.5. So what you think about this? Is our blood acidic in nature or basic in nature, or is it neutral? Okay. So if it was 7, it would be neutral. So it is slightly alkaline in nature, okay. So pH value of our blood is 7.5. Now you know, if you have too much of acidic drinks like aerated drinks and all, what are you doing? You are changing the pH value of your blood, okay. So over here you will see pH scale, okay. As the pH scale decreases, the substance becomes more acidic. As the pH value increases, the substance becomes more basic, and pH 7 indicates that the substance is neutral. Fine? Okay. So students, so far we have learnt about acids and bases. Now one of the important thing that you should know, bases are of two types, okay. So you see over here, base is written at a higher end of pH. Now what you should remember, that bases are of two types, okay. Bases are water soluble and water insoluble. Now those bases which are water soluble, for example, sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide, these bases, when they dissolve in water, they are called as alkalis. Okay. So this is one of the important point that you must know, okay. Bases which are water soluble are called as alkalis, and some bases are not water soluble. For example, copper hydroxide, ferric oxide, these bases are not soluble in water, they are not termed as alkalis. So remember one point, those bases which are water soluble are called as alkalis. Now remember, all alkalis are bases, not all bases are alkalis, okay. So we have learned that pH plays a very important role in identifying the strength of acids and bases. Now besides that, it also plays a very important role in our everyday life, okay. First one, you can see pH in our digestive system. So what is present in our stomach? Which acid is present? Hydrochloric acid. Hydrochloric acid is a strong acid. Its pH value will be low, okay. Now dilute hydrochloric acid helps in digestion of food, especially proteins in our stomach. We already know that partial digestion of carbohydrates take place in our mouth, okay. Now the proteins which are present, okay, it is being digested by the acid that is present in your stomach, okay. Now we know, now if acid is present in our stomach, how come our organs are not getting dissolved? This must be a question which must have come in your mind. So students, remember one thing, the acid that is present in our stomach is having a lining, okay, a mucus lining, which does not allow the acid to come out, okay. So excess acid in our stomach, which is usually caused due to overeating or indigestion, it causes acidity. So what are we already learned, okay, soluble bases, that is alkalis, called as antacids like magnesium hydroxide, also known as milk of magnesia, and sodium hydrogen carbonate, called as baking soda, are used to neutralize this excess acid. Now if at all you don't have antacids at home, you don't have, the pharmacy is closed and due to some reason you are not having it at home, then what you can use? You can use a simple base, that is baking soda, just dissolve it in water and have it, and you will get relief from acidity. So what exactly happens when the amount of acid increases, okay, the pH of our blood will vary. So one of the important role that the pH plays is in our digestive system, okay. Now, tooth decay caused by acids. We all know when we were young, we used to love eating anything that is sweet, you know, candies, and we love eating, we love drinking soft drink, anything that is sweet. And our parents used to make sure that on Sundays at least we have something that is bitter. And they used to always say, brush your teeth twice daily. Now, what was the reason of brushing teeth? The answer is over here. Okay. So, we know that whenever we eat something sweet, and if we don't gargle or we don't brush our teeth, what exactly happens is the food tries to degrade itself. Okay, our mouth, okay, it's having saliva. Okay, now the food particles which remain stuck between our teeth, what it does, the bacteria in our mouth, they start attacking the food. And when they start attacking the food, especially the food containing sugar, they will try to break the sugar into acids. And what are acids? Acids are corrosive in nature. So, the bacteria is present in our mouth, it converts sugar into acids. Now, when the pH of acid formed in the mouth falls below 5.5, we know the pH value, okay, lower the pH value, more acidic is the nature. So, if the pH of acid formed in the mouth falls below 5.5, what will happen? You can see over here in this picture, tooth decaying. So, the excess of acid has to be removed by cleaning the teeth with a good quality toothpaste. Now, the toothpaste that you use, students, remember that it contains a base. Okay. So, it helps to not only keep your mouth fresh, but it also removes the acid from your mouth. So, with a good quality toothpaste, because these kind of toothpaste are alkaline in nature. Okay. So, you have to make sure after having anything that is sweet, you wash your mouth, otherwise the pH of your mouth is going to change. Okay. Soil of pH and plant growth. Okay. One of the most important natural resource that we have is soil. So, now most of the plants have a healthy growth when the soil has a specific pH close to 7. Okay. The range which should be neither alkaline nor highly acidic. Every plant will grow very nicely in a particular soil where the pH is close to 7. So, you can see over here there is a pH scale. If the soil is highly acidic, you see here there are no plants growing, not even weeds, hardly some weeds are growing. The pH between 3, 4, 5, say it's very acidic, you can still see some growth of plants. But when the pH is between 6.2 to 7, you see it is very ideal for the growth of plants. Okay. So, pH plays a very important role in the growth of plant, and we know agriculture is one of the main occupations of our country, and due to rapid industrialization and acid rain, the value of pH decreases in the soil. Okay. So, if you want to grow good healthy plants, you need to maintain the pH of the soil. Okay. So, now we will learn what is a universal indicator. We know indicator is a substance that helps us to identify whether a substance is acidic or basic. So, the universal indicator, it consists of mixture of dyes, okay, that changes its color in different pH. It tells us approximate pH of solution, and so universal indicator is nothing but the pH paper that you have used. Now remember students that universal indicator need not be only in the form of paper, but it is also available in the form of solution. So, the universal indicator or pH paper changes its color according to the pH shown in the chart below, and we have already seen it in our experiment. Okay, now indicators are classified into two types, natural indicator and synthetic indicators. You have already learnt in your 8th standard about litmus paper. Okay, so indicators which are obtained from natural sources are called as natural indicators. Here are a few examples. The litmus paper, turmeric, red cabbage, China rose. China rose is another word for hibiscus flower, or any substance that is highly colored, even beetroot. Okay. So, these are some of the common natural indicators. So, students, you will see over here, I am having in my hand litmus paper. Now, you must be thinking, how come litmus paper is a natural indicator? Litmus paper, you can see I am having two colors, red litmus paper and blue litmus paper. Litmus paper is a natural indicator because it is obtained from a substance called as lichens, okay, which we will be looking at in the slide. Okay, we know lichens are symbiotic relationship between fungus and algae. Okay, so it is being obtained, so litmus paper is being obtained from, paper is not obtained from lichens, but lichens help in the preparation of this dye. Okay. So next we are having synthetic indicators. Those which are synthesized in the laboratory are called as synthetic indicators. Example, phenolphthalein and methyl orange. So you see over here, in the first picture what you see, this is lichens. Okay, lichens, what we obtain is the litmus paper. Next we are having turmeric and China rose. Now let us see how the litmus paper helps us to indicate whether a substance is acidic or basic. So first we will start with red litmus paper. Again I am having two unknown solutions A and B. If I take this red litmus paper and I dip it into the solution called A, do you see, is there any change in the color of the litmus paper? No. Okay, since there is no change in the color of the red litmus paper, okay, we will say that the solution present in beaker A is acidic in nature, because if red litmus paper does not change its color, the solution is acidic in nature. Suppose we take the same red litmus paper and we dip it in the beaker containing some unknown solution. Over here you have seen that the red litmus paper has now changed to blue, indicating that the substance is basic in nature. So what you have to remember is, this beaker that you see over here, blue litmus has changed to red, that means the beaker A is acidic in nature. Litmus paper only helps you to indicate the nature of the substance. pH paper helps you to understand the strength of the acid or bases. Okay. Now if we try it with blue litmus paper, if we dip blue litmus paper into the beaker labeled A, you see instantly there is change in the color of the paper. Blue litmus has changed to red color, that means the substance present in A is acid. Okay. If I dip blue litmus paper in the beaker labeled B, there is no change in the color of the litmus paper, showing that it is a base. Okay. So you see indicators are very helpful in indicating whether a substance is acidic, basic or neutral. Okay. So wait, now litmus paper is giving us a change in color from red to blue. That does not mean all these substances like turmeric and China rose is going to give us the same change in color. Okay. So next we will have a look at synthetic indicators. Examples of synthetic indicators are methyl orange and phenolphthalein. Now there is a clear change which is shown over here. Methyl orange indicator, it remains in red color in acidic solution, whereas in alkali it changes into yellow color. Okay. Now let us have a look at phenolphthalein indicator. Phenolphthalein is another synthetic indicator. So we will take two test tube. In one test tube we will add the solution from beaker B, and we will add few drops of phenolphthalein indicator. See students, right now the test tube is colorless. Now on addition of phenolphthalein indicator, you see immediately the color has changed to pink. That means phenolphthalein indicator indicates that this substance is basic. So from colorless, when the substance changes to pink color on addition of phenolphthalein indicator, it indicates that the solution is basic. Now we will take another test tube in which we will add the contents of beaker A. On adding few drops of phenolphthalein indicator, you see that there is no change in the color of test tube labeled A. That means phenolphthalein indicator does not change color in acidic solution. Okay. So methyl orange changes to red color in acidic solution and yellow in alkaline solution, and phenolphthalein indicator, it changes its color to pink in basic solution and it remains colorless in acidic solution. We have learned two types of indicators so far. We have learned about natural indicators and we have learned about synthetic indicators. Now there are third type of indicators which are called as olfactory indicators. Olfactory indicators are those which change their smell when mixed with acid or base Okay, for example, onion, vanilla, etc. So onion, what you have to do, you make a paste or juice of onion and it will lose its smell when it is being added with base. Whereas in case of acidic substance, it is not going to change its smell. In case of vanilla, the smell of vanilla vanishes with base. That means you are not going to get any peculiar smell, but its smell does not vanish with an acid. Now you will think why we require olfactory indicators when we already are having phenolphthalein, methyl, we are having litmus paper and so many other indicators. When we can do something physically, why do we require olfactory indicators? The most important reason behind this, it is required to ensure the participation of visually impaired students in the laboratory. Okay. So that is why olfactory indicators are important. Indicators are substances which changes the color in presence of acidic or basic substance. Okay. Red litmus paper, what is the original color? Red. In acidic solution, it is not going to show any change, but in basic solution, it is going to change in blue color. Blue litmus paper original color is blue. In acidic solution, it changes to red, whereas in basic solution, it will not undergo any change. Now turmeric, original color is yellow. In acidic solution, turmeric is not going to show any change, but in basic solution it's going to turn into reddish brown. So sometimes what happens, suppose you are wearing white and you eat food, okay, colored food, and if it falls on your dress, you know there will be stain which will remain. Now if you go to wash that stain, it is not going to go easily, but on application of detergent, immediately that yellow patch is going to change into reddish brown in color. That means in the presence of base, turmeric changes into reddish brown. Red cabbage juice original color is purple. In acidic solution it changes to reddish, whereas in basic solution it changes to greenish yellow. Phenolphthalein indicator is colorless in acidic solution, but in basic solution it changes to pink color. Methyl orange indicator, the color is orange. In acidic it will show red, whereas in basic it is going to show yellow in color. Whereas onion, that is an olfactory indicator, we know there is no color, okay, but in acidic solution the smell of onion is not going to change, but in case of base the smell of onion is going to vanish, and you know onion is having a very strong smell. So it is very, very important for visually impaired students, okay students. So students, in today's class we have learnt about properties of acids and bases. We have learnt about types of acids and bases, that is organic acids, inorganic acids as well as bases. We have learnt how to carry out dilutions of acids and bases, that is you have to slowly add acid to a beaker containing water, okay, and stir it very slowly. Then we have learnt about pH scale and its importance, which is also called as a universal indicator. And then we have learnt about different types of indicators, natural indicators, synthetic indicators and olfactory indicators, okay.